saying that the construction of CFG. Now here this derivations and parse tree. Derivations and parse tree of the grammar. Okay, so derivation means if any grammar is given which is having the components VTPS. Okay, we have discussed VTPS is variable, terminal, productions and start symbols. So if any grammar is given here, there is a context free grammar. So by the rule which is given in the questions, you can derive the string. Okay, so that is called as derivation only. Okay, so you can write it here, the generation of language using a specific set of rule is called derivations. Like example, if you given here, like S is equal to A and A is given, and this is epsilon. So this one, if a grammar is given, you want to derive like 3A. Okay, so you can do it by S is equal to A and this A. Then A and this, in the place of this non-terminal A, I can substitute the value of A, right? A and A. Again A in the place of again this variable, non-terminals, I can substitute it again A. Now we already got it 3A, so it will end it this non-terminal. We'll put in the place of A is epsilon, so we'll get it 3A, right? Okay, so this is all called as a derivations. This is all method, means all the steps which you are doing it to derive the string that A is called as derivations. Next is parse tree. Parse tree. Okay, so this derivation tree is represented graphically is called as parse tree only. Okay, like here what we have done, we can represent graphically here, like S is equal to, I substituted AA, so I can write A and this A. Again in the place of A, I written this one, A and A. Again in the place of A and A, and this finally A is epsilon. So we are here also, when you pass it here, we are getting A and A, which is triple A. And this was the grammar. So this is only called as a parse tree. Graphical representation of derivation is called as parse tree. And the property of the parse tree is, you can say that this one, the root of the node, is always the starting symbol. This one. Okay, so root node is always a node indicating the starting symbol. Getting? And these derivations we have to read from left to right, like which are the way I have read here. This A, without removing the pen, you can read it from left to right. A, and this one is what in here. Getting here? The leaf should be always terminal. This is leaf, right? Pendant vertex. This is A and A always should be, and this epsilon also. So leaf will be always that terminal. Root will be your start symbol. Getting? And the interior node which is given like this one, all is non-terminal. This is non-terminal is what here? S and A. So S is there in the root and A all is the internal node. Getting here? So now there are two methods to derive it here. Okay, derivations is actually we can do it by the two method. These derivations can be done by the two method called as leftmost derivative derivative is also called as LMD. Okay. Another is rightmost derivative, which is RMD. Okay. So LMD means we have to substitute, like consider if given like any grammar here, S is equal to A and B, where A is a small a and B is that a small b. This one is given. So when you are deriving it here, so LMD, when you are doing the LMD method, so first we should remove this left hand side. This we have to put in the place of left hand side non-terminal. First we have to substitute in the place of this left hand side. Getting? And when it's become a terminal, then only you can go to the next non-terminal. Similarly, for the right most derivative, RMD, first we have to substitute the value of b from the right hand side, from this way. Getting?
Yeah.
So I will take the example, then you will understand more better here. So here, if given here like A derives plus EE or star EE minus EE and that X and Y. So E means that like expression. Okay, and we have to derive the string that plus star minus xy xy. This one you have to derive it. Okay, by using the first LMD I will do it, then RMD will. Okay, so here we are free to take here either this one or this one or this one, because OR is OR given, right? I have discussed in the last class this one. So here, but we in the string we required first one is plus. So we have to choose this one only, right? Because this one can't win, because this is multiplication and this is subtractions. So first we have to substitute this E derives plus EE. Okay, and we are doing by using the LMD. So first we have to remove this left hand side non-terminal. So I will write it here. This is LMD, we are doing it here. This is terminal here. Terminal nothing to do. This E, in the place of E, what you can substitute here? This all you can substitute, but we want here a star. This multiplications, because plus is already done. Now we want to derive this multiplications. So I will substitute this one in the place of E at left hand side E. So I write here a star E E and this E as it is only. So I written here in the place of E a star E E. Any doubt in this?
No.
So now here we got it plus and a star. Now we want minus. So plus a star we got it here. Now we want minus, then you have to substitute this one in the place of this E. Right? So you can write here minus and again double E. Because of this one double E, another 2 is as it is only. So we just simple example I have taken minus EE as it is. Okay. Now plus got it, star you got it, minus you got it. This one you have to substitute it. What you will have to find it? What you have to get it here? X. So we will substitute in the place of E is what? X. This remaining will be as it is now. Next again similarly LMD plus star minus X, and this E I need Y here. So I will put the values is Y. You have to do a step by step. Okay, so you cannot do all together. Okay. Minus X, Y, then X, and then E. E derives X. And here.
So we can't change everything at once.
No. I have to show that step by step. It's parsing here, no, that's why. Getting here? So now finally you have got it, this the string which you have to pass it. And we have put the values of this non-terminal always from the left hand side, right? Here also first I substituted this one, then I substituted again this left hand side, okay? So this is called as LMD, leftmost derivative. Now you have something you have to do from the RMD. Tell me, RMD how will you do?
So again,
So again we need plus here. So I have to choose this first. E derives plus EE. Okay. Since we are doing from the RMD, we cannot substitute in the place of this one, right? We need to first substitute this right hand side value. 1 plus, as it is only E. This E, what you can write here? Y, because right hand side the value is what here? Y. We will deriving from the just opposite way. Y. Then plus, now here right hand side there is no terminal here, right? This one, this is not non-terminal, this is terminal, right? So now only one non-terminal is left, so I have to substitute in the place of this E. This one I written here, E derives Y, so you can write it. So now the option is only this one. Only one option is there because only one non-terminal is there. So now in the place of E, we can write it what? Star E. Okay? This Y as it is only. And this one we have done in the RMD only. Now RMD if you do here, plus star E. You have to substitute in the place of this one, right? Because non-terminal from the right hand side is this, right? Now what we need here, Y already got it, X we need. So I can write here X and this Y as it is only. So here I written here E derives X and here we got E derives star E. Getting any doubt in this? Now plus star E. Now only one E is there here, so I have to get it minus. So I get minus E E. This X and Y as it is on. Now from the RMD plus star minus this E as it is only, in the place of this one I can write it as a Y, right? And now the last is plus star minus, in the place of last only E is there, we need X, so XY XY. Any doubt in this? So finally by using the RMD also you got it the same string, this one here. Getting? Now you have to derive the parse tree, parse tree. So parse tree, by this one whatever I have written here, by using this one you can draw the parse tree. So first is what? E derives I taken as a plus and EE, right? This one, first one, plus E and E. Then after that E is a E star E, star E and E. Then minus E and E. And this E is X, this is Y, this is X, this is Y. And if you read it from this way, you will get it plus star minus and then X, Y, X and Y. So we got it same thing here, this one. Okay, similarly from the, if you draw the parse tree from the RMD, okay, by using the RMD if you draw the parse tree, we will get it like E derives plus E and E. Then here again I substituted here E derives Y, and this E is star EE. Then this one E is X. Then this is minus EE. Then again this is one star EY. X. That's minus E. So this value is Y and this is X. So you got it here plus star minus XY and X and Y. So if you see the parse tree, both parse tree is what same only. Both parse trees look like a same only. So when you are doing whether the LMD method or RMD method, so this parse tree will be look like a same only. This will be not change. Only when deriving manually here one by one, that LMD and RMD will be different, but parse tree will be the same. Getting either whether you by using the LMD or RMD, if you do the parse tree, it will be the same. So this is the question is given here. This is the questions asked in the 2019 BTU exam. Okay, so last year was there. So here we have to derive this A plus B into C by using the LMD and RMD, and then you have to check the ambiguous. That part I will teach later. Let's first derive LMD and RMD. Okay, so first I am doing for the leftmost derivative. So leftmost derivation, which one we can choose? E derives E plus E I can choose, yeah, minus I can do it, multiplication also I can choose, division and this open bracket no need to choose here. Okay, yeah, the open bracket also is given here. Okay, so first thing we have to choose this open bracket, right? E derives this open bracket and close bracket. We can write here E and E. If this bracket is not there, then we no need to do this one. Only you should take E plus, yeah, E minus, yeah, E into E, because only it will be involved that plus and multiplication. So plus and multiplication you can choose. Since here bracket is also there, so we are choosing here that open bracket and close bracket, this one. Now that open bracket as it is only, open bracket is terminal here. This E I can write either E plus E or E into E, because in our string it's involved plus and multiplications. So I'm substituting the plus things first. So E plus E, I put it here in the place of E plus E. Now we are doing from the LMD, so this one I have to remove first. So this one in the place of, I can write A plus this E as it is only. Next, this open bracket as it is only, A plus this E I can write here E star E. So I written here E derives E star E. Next here A plus this E I can write B. And this is A plus B and this star, and finally this E is a C. Getting it? So we got the string A plus B star C by using the LMD. Getting? Now same string you derive by using the RMD. E derives, first we have to choose this open bracket, only one is there, so this E have to choose. Now only one E is there, so we can substitute it. This E is E plus E. Okay. Now RMD. Since we have to do from the right hand side, this we have to substitute here. So E plus, I can write this one E as a E star E, because ID star ID, the B into C required in the last options, right? So if I write it here C, then we will not get here multiplications. So here I written here, I will write E derives E plus E. Here we written E derives E star. Getting? Next is E as it is plus E, and this in the place of I can write C. E plus this one is a B, C as B. Next RMD, that E is what A here, A plus B star C. So we got the same thing by using the RMD. Any doubt till here? Let's draw the parse tree also. Then we'll check about the second one. Parse tree we can draw it here. E derives E plus that first I written here open bracket. That E and this close bracket. Here. That E derives open bracket E and close bracket. Then this E we can substitute in the place of E plus E. We have done here E plus E. Then this one has a E star E. This one as A, this is B, this is C. So if you get it here, this open bracket A plus B star C and close bracket. So we got it here, same thing. Okay, any doubt till here? So this is about the LMD, RMD, and if you given the parse tree, then you have to draw this. Now another, what is that? Ambiguous. Okay, ambiguity. So first I will define the ambiguity, then we will discuss about the same question for the ambiguous. Ambiguity definitions, I will write it here. Any given a grammar is said to be ambiguous. Okay, yeah, ambiguity if it has more than one LMD or RMD or parse tree, anyone means LMD. If also you have to not prove LMD and RMD both, you have to do only LMD and have to show that you can derive it more than one for the same string. So a grammar is said to be ambiguous if it has more than one LMD or RMD or parse tree for the given string. Getting? Like here the question was there here, E is equal to E plus E, E minus E. Let E star E and E divide E. And E is open bracket E and close bracket. E is A or B or C. So we need to derive that time A plus B C, that open bracket B into C. So we have done in the LMD, right? LMD we have done E is equal to E plus E. I'll do it fast because already I have explained before. E I can write it here. Sorry. That open bracket E. Then this E plus E we can write A plus E. Then A plus, here E we can write E star E. A plus, this is B into E. This is A plus B into C. Getting here? This all we have done in the LMD. So by using the LMD, what I have done in the first one, that open bracket and close bracket of this one e. Then this e I substituted the value is e plus e. Okay. Now e is, so now their option was there for the e to put it plus also, minus also, in multiplication also, division, and so much e option is there. But we have chosen only plus here. Why? Because the questions, our that string was involved only plus and multiplications, right? So consider if you are able to draw the one more LMD by choosing the different derivations, and if you got the same parse tree, then it's said to be ambiguous. Okay, so I am doing by the LMD only. What I will check here, e open bracket e, that is fine, same thing I have used. Here in the place of plus, if I will substitute multiplications, e star e, let's say we are able to derive this one a plus b into c a naught. So e derives, I can write it here, this e, you can write here e plus e, okay, star e. Then this is a plus e star e, this is a plus b star e, this is a plus b star c. Okay, so we are able to derive when we are substituting the different string. Okay, see here in this derivations what you have substituted here, derives e plus e, right? This one we have done. Here e derives a, we have done. Here again e derives e plus e star e, we have done. Here e derives b and e derives c. But in this one we have changed the order, we have not done the same. Here we have first chosen e star c, e star e, then e is equal to e plus e, then e is a, e is b, and e is c. Okay, so in this case here we have substituted this multiplication first and plus later here, getting here. So if by choosing the different here we are getting the same string, which means there confusion is there, parser will confuse which one to choose, right? Like consider here, if for example if you take here 2 plus 3 into 4, so first we need to multiplication first, and then you should add it these values, right? 2 plus 3 into 4, 4 into this 3 into 4, 12 plus 2, 14 is the correct answer. But if you add it and then if you multiply, you will get the different result. 2 plus 3, 5, 5 into 4 is 20. Okay, that is wrong. So why here? Because we having the priority here, first we have to multiply, Bodmas rule we have to apply. And here in this case, if we are doing it here, the parser is, if we are adding first, then also we are able to draw the id plus id star id. Yeah, a plus b into c, means 2 plus 3 into 4. They are able to parse it when they are doing the addition first. When they are doing the multiplication first, that time also they are able to parse it 2 plus 3 into 4. So here parser will confuse which one to choose. So means in the calculator, if you given this programs here in the computer, any programs, so here parser will confuse which one to choose here. So this is this is called as ambiguity only, that confusion, that ambiguous grammar. So we have to remove this ambiguity, and we have to make sure that for the given one string we need only one particular only the derivations. It should not exist more than one derivation for the given grammar. Okay, so here we are able to draw these two LMD for the given string by using just different substitutions. So this is called as ambiguous. Okay, so we write here the grammar is ambiguous. Getting? If you see the first grammar, this one here, which I have done, this grammar, I did LMD. Okay. If you do the LMD by changing the different order here, you will not get it. See here, because we required plus here, that's why we have to Firstly we have to choose this only, right? We cannot take this one, we cannot take minus here first, because there is, for the string first symbol is plus here, so we have to take plus e only. After that e, this one here, again we have freedom for choosing all the four, but we cannot do because we need multiplications here, and then we have only one option left, this one here, right? So this one I substituted here, this star ee. Then after that negative was there here, minus, so only this one you can substitute. Another you substitute, you will not get the string only. So minus is there. Then after that here option is there here x, because we need x only. So you cannot put y, because for the given grammar we have to substitute the x only. So xy. So here is no any another way we can pass the same string. Okay, for the, okay, understood what I am telling, right? We can, no another method exists for deriving the same string. So this is non-ambiguous. Is also called as unambiguous. Unambiguous grammar. And if it has more than 2 LMD or RMD, then it's said to be ambiguous. Any doubt till here? Hmm? One more questions I will do it. Question is given, check the grammar is ambiguous or not. X is given ICTS and another is ICTSES and S is A and C is B. This one I have to check out. Okay. So here a string is not given. If string you can derive by on here, and you can check out for the different cases. Like S derives here, first I will choose ICTS. Okay. Again in the place of C I can write it B, right? IBTS. Now in the place of IBT, as it is only in the place of S, I can substitute this one, ICTSES. First I will write it here what I am doing here. See where B I did, here S derive ICTSES. C is non-terminal. IBT I and C is B T. S I can put it A E, and again A S I can put it A in the next step. Okay, here I did 2 steps ahead. C is B here, IBT, and this is A is AES. And this is again A. Getting here? So we got it, this string, by working with the LMD with this one order of the string. Now you check out here if that time I had chosen this one, right? ICTS. Now you choose different and let's try to derive this one. If we are able to derive, then is unambiguous. If we are able to derive, then is ambiguous, otherwise unambiguous grammar. So let's draw it here. S derives ICTSES. Now I want this one IB. So I will put it TSES. Put it C is B. Next IBT. This S. IBT is over here. IBT over. Now again I want. Okay. So I can take this one only. ICTS and ES as it is. Then IBT, this I, and C I can write B T S E S. So we got it till here IBT, and here this one I written C there IBT, and I can write it as a AES. IBT and AEA. So we have got it at the same string here, this one, by using the different orders. Okay, which means this grammar is unambiguous grammar because it exists more than one LMD.